I'm Charlie.
I'm Ed.
And we've lived and worked aboard a huge variety of vessels since we both left school. We've worked on tool ships, warships, marine conservation research vessels and Antarctic expedition vessels, and a whole load of other kind of boats in between. These days we live aboard our own boat in the Hebrides, and we own an online sailing school. When Ben said he'd like us to come back and speak again this year, I asked him if there was any particular topics that he'd like us to talk about. And he said, "Do you guys do anything about celestial navigation?" And I'm not sure if he knew at that point, but that happens to be pretty much our favourite subject. So...
yeah, our little nerdy hobby.
So it was immediately obvious which trip we should talk about, because there's one special trip that stands out to us. And it was the first trip, the first ocean passage that we did without the use of GPS. And in the front page of that notebook, which I have here, we titled it 100 Degrees of Latitude. And the reason for that is our departure port was Gosport in the UK, and our destination was Stanley in the Falkland Islands, which just so happens to be 101 degrees of latitude, so maybe we got the name wrong there. It's roughly 8,000 nautical miles, and the trip took us exactly 2 months.
So why were we going from Gosport to the Falkland Islands? Well, we, at the time, were working on this research vessel, Song of the Whale. We still do the odd trip on there now. And basically, this boat's out researching whales and dolphins, and they had a survey to do in South Georgia, studying right whales. And this was pretty much the delivery to get it down there for that survey work. But this boat doesn't go anywhere without doing a bit of research along the way. So whilst we were underway, there we go, that's changed. On this boat, we've got lots of interesting kit for the science. So in the top right, that's us deploying hydrophones. We're two 400-metre long hydrophones, underwater microphones that we tow behind the boat, and we listen to the whales and dolphins because they're only on the surface to breathe. Most of the time they're underwater. So if you can hear them, you can find out a lot more about them. Because we're doing acoustics, I haven't got a picture of it here, but the boat has a really cool propeller which looks like it's straight off a submarine. It's really flat, and makes the boat really quiet. You can hardly hear it going through the water. The engine's also obviously extra quiet. At the back we've got an A-frame where we're also doing visual observations, visual surveys. So we're stood 6 metres above the water, eye height, and a crow's nest up the mast for the calm days. On top of that, we've also got on the far right, that's called a manta trawl, and a couple of times a day we would tow that behind us and collect microplastics, basically a really fine net. We pick it out, get the tweezers out and the microscopes and count the microplastics in the area. And also we'd be collecting environmental DNA samples. So every 100 miles or so we'd stop, take some water, filter it until we can pick out DNA from that seawater. And we were also trying to get samples from the animals themselves so we could tell which animals have been in which areas, just basically taking a sample of water and filtering it.
For some reason we decided that all of that wasn't enough, and we also wanted to take our hobby of celestial navigation to another level and attempt the entire trip without GPS. We'd both been doing this a little bit beforehand already. I've been studying it for about 2 years and taking sights in my lunch breaks at work when I was working on other vessels. And when Ed met me, he decided he'd sharpen up his skills as well. But we'd never done a trip like this before, where we did the whole trip with celestial navigation alone. So for us, this trip was all about deepening our knowledge.
Yeah, we really wanted to go from we can do it to we really understand it and know it.
The main tool for the job, of course, is the sextant. It looks a little complicated and also kind of cool, but it's a pretty simple instrument, really. We've got a telescope, we've got 2 mirrors, and some shades which protect your eyes. along the bottom here, there's a scale in degrees. And the idea is to try and find the angle between a celestial object, that could be the sun, it could be the stars, the planets, or the moon, and the horizon. And so when you look up at an object, the light from that object goes through the mirrors and into the telescope. We set the sextant to 0, and then as we tilt the sextant down, keeping the needle in place on the scale, a reflected copy of that object starts to come down to the horizon. As it starts to get close, you can fine-tune it with the micrometer drum on the front, and just when it kisses the horizon, you want to take the time, write it down to the very second, and read off the scale from the sextant. And it will give you the angle to a 600th of a degree. So it's a very accurate instrument.
But I wish that was the only tool we needed. That's the fun bit. But also we need lots of books. And we've bought a couple here. But to start with, we need the Nautical Almanac. And this basically tells us where the sun is, where the stars are, where the moon is at any time, any day, to the second, exactly where it is on planet Earth. And then we got this book, and after we take the site, we take some numbers off the sextant and some numbers out of there, and we put them in this book, flick through lots of tables, and we get other numbers out. And this is basically a calculator in paper format. Put numbers in, numbers come out, and it does spherical trigonometry for us. It's a very clever book. You actually need sort of 5 to 7 of these to do the job, but we only brought one with us today. It's quite a lot to take in your airline luggage. And when we're doing all these sums, we're writing them down. So we've got our notebook here where we're doing, dropping bits now, doing all our maths, and it's just pages and pages. Every page of this book is full, every line with sums that we were doing along the way. What else have we got? Plotting sheets. When we're navigating across oceans, our charts, they'll show us we've got America on one side, Europe on the other, loads of deep water in between. And it covers thousands of miles. And it's really useful for saying, yes, it's 4,000 metres there, 4,500 metres there. I don't really care about those depths. It doesn't really matter to us, whether it's 4 or 4.5. But the scale is useless. We can't draw on that. It's thousands of miles in just a short space. So we end up making our own charts every day. And these plotting sheets allow us to make our own charts at our own scale. That's good for us to work on. There's no depths on there, but like I say, we didn't really mind when we're in the middle of an ocean. We also need a timepiece, so a watch. And the important thing, the watch, no watch is perfectly accurate, but we need to know exactly the second of the time. What we ended up doing is a couple of months beforehand, we started studying all our watches, lining them up, checking them every day, and finding the one that was the most consistent. And one of my watches went 4 seconds, it lost 4 seconds every week. The important thing is, it's really consistent. So after 6 weeks, we can say, well, we know it loses 4 seconds a week, we can still work out what the precise time is. So it doesn't always keep perfect time, but it's consistent. And last but not least, one thing we didn't bring. When we learn celestial navigation, we always get these pro formas, and it's like boxes. You fill them in, it tells you what to do, and out at the end comes your position. I bought a load of those. Charlie ripped them all up, put them in the bin, so we're never going to learn it that way. And made us do it the hard way. She gave us that notebook instead.
When we left Gosport in November, it was probably as you would expect the English Channel to be in November. It was wet, rough, and pretty miserable, and it wasn't very easy to take sights at the beginning. But we persisted, and it was taking us about 45 minutes on a good day to go from taking a sight to getting our position on a chart. Often it was taking over an hour. And when you're doing all these calculations, it's so easy to make a mistake. And then it's quite hard then to go back and see where you've made this mistake. So we were taking a couple of sights a day and taking it in turns, but very often we'd swap our work and mark each other's work, if you like. So even that was quite time consuming as well. Sometimes it would take me 20 minutes to go through each line of Edd's workings just to get to the very end and then say, 4 + 2 is not 8, Edd.
I mean, it was rough and tiring, that's my defence.
So some of you are probably wondering how we actually go from taking an angle to getting a position on a chart. Now, I've only got a few minutes to describe it here, but we'll do our best. The first thing that you need to learn about is something called a GP, which is a geographical position. And the concept is that all of the stars, planets, the sun, they all have a position on the Earth. To try and visualize that, you could imagine a string that goes from the center of the object to the center of the Earth, and where that piece of string crosses the crust of the Earth's surface, that would be the GP. And humans have been studying celestial bodies for many centuries, and we've gotten really super accurate at calculating exactly the GP of all of the stars and solar system, down to the very second, thank you. And so what you need is a nautical almanac. This tells you the position to the very second for each year. So you need a new one each year.
Now, if you imagine, if we know exactly where the sun is, if we looked up and the sun was directly above us, we would also know where we are. We've got the sun's GP. Look straight up, we can measure at the sextant. It'd be 90 degrees from the horizon to the sun. We know exactly where we are on that GP. But that's not the case in reality, is it? It's never directly up. It's normally off at an angle somewhere. If we know where the sun's GP is, if we can take the angle to the sun from the horizon and see how different that is from 90 degrees, long story short, we can actually find how far away we are from that sun's geographical position. So the sextant just measures horizon to the sun, and we can use that to work out how far away we are from the GP.
So what you end up with is kind of a radius from the GP. And if you had a chart big enough, a chart that nearly covered the whole world, it would end up with a gigantic circle. And for sailors amongst you, that would be a position line. That means we know we are somewhere on that line, even though it's a circle. If you then can take 2 of these objects, like the sun and the moon, for example, and get 2 position lines at once, then where they cross is your position. That's very, very simplified, of course, but we've only got 25 minutes for this talk.
Just to give you a hint of some of the things we're glossing over and why our calculations ended up being so long. There's some of the things we have to consider, some little adjustments we have to make, for example, parallax correction. That's where this works perfectly if we're stood in the centre of the Earth. We're obviously not, we're on the surface of the Earth. So we have to adjust for that distance, that change in our position. Refraction. The atmosphere bends the light as it passes through. So when we're measuring the angle to the sun, we're not actually getting it exactly right. So we've also got to work out how much atmosphere it's passing through and how much that's going to be bending the light, and again, adjust our angles. And the list goes on and on and on, and you end up with pages and pages of relatively simple sums, but lots of them.
Contrary to what the romantic images of celestial navigation brings, which usually involves staring at the night sky and taking sights of stars, actually, by far the most commonly used celestial object is the sun. It's big, it's yellow, it's hard to mix it up with anything else, and the hours that it's available are very sociable. Also, having the sun and the moon at the same time, whilst that's really, really convenient, it's pretty rare. So more often than not, we just use the sun. Looking at stars, planets, and the moon, they're all a little bit more tricky. There's more calculations to do. With stars, it's really quite hard to be confident that you've got the right one sometimes, and the opening hours that they're available are much less civilized.
So practice, 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 and by the time we reached the Bay of Biscay, the weather was improving, contrary to what people normally think the Bay of Biscay, but our sights were improving as well. We were getting a bit slicker at this. And it's good timing, really, because about this time we noticed there was something odd going on with our batteries. Looking through the logbook, every hour the voltage was up, it was down, it was here, it was there, and we were kind of like, this is not quite right. There should be nice steady drop as we're sailing along. And it was interesting because actually it's probably the only thing that was going to stop us using GPS and make us solely rely on sextant is losing the battery bank and all our power. So we crawled into the Canaries and decided to open up the battery box and have a look. And this photo shows you what we found. So 3 or 4 of the batteries had these massive cracks in them. And this was pretty scary for us. We looked at this and we thought, hey, let's put that lid back on nice and gently and get our faces out of it before we risk getting some acid to the face. Yikes. Needless to say, big, expensive job. These batteries on the research vessel, they weighed about 70 kilograms each, so were thousands of pounds. We had a lot of them to replace. Getting them in and out, that's a whole nother story for another day. Don't have time for that right now. Back to Celestial.
Like Ed said, by the time we reached Cape Verde, we were getting really confident with our sun sights and really slick at getting the calculations done. We had been checking our calculations against the GPS every few days just to check that they were accurate and they were on track. Actually, we were kind of chuffed. They were looking pretty good. And now we're not just taking sights of the sun, but we've started to experiment with the moon, the stars, and the planets as well, each one having its own unique challenges. The next leg was going to be the biggest leg yet, 4,500 miles, and we both committed to each other at that point that we were never going to look at the GPS again until we arrived at the Falklands.
So, a little break from Celestial. This is just a fun coincidence, but when you're sailing in this part of the world and you get the trade winds, we had very consistent wind from very consistent direction, and for 3 weeks we were on the same tack. We didn't reef the sail, we hardly had trimmed the sail at all. It was just keep going, straight line, same wind, and by the time we tacked after 3 weeks, we all started falling over. It felt like one leg was longer than the other, because we'd been on the same angle for so long. Yeah, bit irrelevant, but it made us giggle.
As I said before, the stars are a little bit harder, but the advantage is that you can take multiple position lines at once and get a super accurate position with just one set of sights. And you feel way more badass when you're taking sights of the stars than you do the sun. So we started learning the constellations, and night by night we'd learn a couple more stars to add to our collection. But the best star of all, well, of course, that's got to be the pole star. The pole star, or Polaris, or the North Star, it's an absolute freak of nature. It's amazing. It really does sit exactly above the North Pole, which for navigation is awesome, because literally you can take your sextant, take a sight to the pole star, and it's literally 90 degrees minus the angle on the sextant gives you your latitude. That's it. No whole page of calculations, just 90 degrees minus this equals latitude. Incredible. But each night as we came on watch, of course, we're travelling south, and also due to the watch rotor, I'm coming on watch like 3 hours later each night because of the way the watch rotor works. And so this pattern in the sky that we're starting to become really familiar with, it's starting to roll forwards or roll northwards as we travel south, and it's also rolling slightly more west each night that I come up on deck. And so it really feels like we're actually sitting inside a clock. It's really quite spectacular, and I've got goosebumps just thinking about it. And just as we approached the equator, we had to say goodbye to the pole star, which was a very, very sad day. And the day after we crossed the equator, just as you would expect, we started to see the first signs of the Southern Cross. It's really amazing to experience that. And when you're out there every night looking up at the stars, it just puts it all into perspective how rubbish the Southern Cross is compared to the pole star. Absolutely rubbish.
Yeah, there's no 90 degrees minus sextant angle for latitude of the Southern Cross. It's not even south. We never used it. After crossing the equator, we had our next challenge, which was passing underneath the sun. And when we'd been learning celestial navigation, we'd always been told this is going to be a big challenge. Because despite what I said earlier, if the sun's directly above, all we need to do is see where the sun is, and that's where we are. Well, I was lying to you, that's rubbish. It's pretty much impossible to tell when the sun is directly overhead. If I take that sextant and I do my best, it would be pretty much 90 degrees, but I don't know which horizon to bring it down on. It might be 89.9 there, and it just, trust me, it doesn't work. Especially when you consider the sun is traveling so fast, it's moving a mile every 4 seconds. So yeah, it doesn't work. But it didn't faze us at all. We were quite happy. We did a moon mare pass that day, which I was pretty pleased with, which not many people do these days. And we were getting the sights and the stars and the planets, and yeah, we were feeling pretty good. Everyone said this is difficult, didn't bother us. So we realised we're taking our knowledge up a level here, and also, you know, where it was taking us an hour to get the sextant out, get a angle, put it on the chart before, now I was sleeping with the sextant next to me, and when if someone spotted a good opportunity to get a sight, I'll be like, right, up with the sextant, on deck, bang, down to the chart table, do some sums. Less than 15 minutes, I was back in bed again. It's a big improvement, lots more sleep. But just as we thought we were getting the hang of it, obviously there's more challenges, and the further south we get, the rougher it got. Falklands is 51 degrees south we were going, and yeah, they call that the furious 50s because the sea gets rougher and rougher. And remember, we said we're trying to measure an angle to 1/600th of a degree. I don't know how accurate my sight was that day. It definitely wasn't perfect, but you know, you take that into account. When I put that one on the chart, I took it with a pinch of salt. We were somewhere near there. The other challenge was it got cloudier too. And I would go to bed and I'd leave a little note on the chart table. Wake me up if you think you might see a sun, a star, a planet, or the moon. And yeah, someone would knock on the door. I'd run up on deck. I'd sit there with my sextant, stare at a cloudy sky for an hour, and then go, "Nah, it's not coming." Go back to bed. Might go a day or two without getting any sights at all because it's cloudy. What can you do?
And finally, we reached the Falklands, and by some stroke of luck, they were right on the bow, was our first sight of land. So, I mean, an absolute moment of celebration for us. They were exactly where we expected them to be, and for the rest of the crew, I would imagine an enormous sigh of relief. We, at that point, took the opportunity to confirm our last celestial position against the GPS. And the result was less than 1 mile in difference. So we were hugely satisfied with that. In general, it's considered a success if you get your positions within 10 miles. So to have done 4,500 and get a result with less than a mile, I mean, we were happy.
You can see how smug she is. But it did get us thinking about the relevancy of celestial nav, because you know we always had access to GPS if we needed it, and in reality, even losing all the battery banks on the boat these days, we've got handheld GPSs, we've got GPSs on our phone, we've probably got enough if we are sparing with the battery usage to limp us back into port. And so maybe it's not the most relevant for navigation these days, but the sort of depth of knowledge, the understanding, and the real sort of seamanship that you develop doing this is very relevant. And we really felt we grew a lot as sailors on this passage. It was also obviously very rewarding. We've done lots of trips like it since because we get a kick out of it. But being able to do all this manual navigation, we really got a sense of, we could lay in bed and feel, I think the boat's going this fast. We could feel, I think we're getting this much leeway, we're getting pushed sideways by the wind. We could really start to get in tune with it because we've been paying so much attention to it. What's more, we come up at night and I could tell if someone turned the boat, because I could come up and I could tell you where all the stars were going to be before I looked up. And if I looked up and they were in the wrong places, hang on, what's going on? Have we tacked? So yeah, we felt like it developed our skills as sailors a lot more, and like I say, so much reward out of doing that trip. If you compare that to driving a little boat across the screen on your GPS and just setting the auto helm to follow route, it's hands down a much better way to get the most out of any ocean crossing, in my opinion. Not to mention the fact that we were on this really cool whale and dolphin research vessel with a load of scientists taking DNA samples, photo ID, acoustics, recording everything we could hear. And you know, here's just a few shots from that trip. But we had 25 minutes for this, and that's 25 minutes on the dot, so we're going to have to save that for next year, I think.
I hope you've enjoyed this little introduction to navigation and celestial navigation. And if you'd like to come and say hello, or you've got any questions, we're actually just down the other end of the hall at stand J134 with our stand Ardent Training.
Okay. Sorry. Thank you, Charlie. Thank you very much.